And we're back and better than ever, still in 12.2 doing chemical calculations. In this podcast, we're going to continue our development of our understanding of the mole ratio. We're going to keep practicing identifying what the mole ratio would be when you're changing from one species to the next. In this particular equation, example number 2, let me get my pen ready here. In example number 2, we have C3H8, which is actually what we call propane. Propane reacting with oxygen to form carbon dioxide and water. The ratios are 1 to 5 to 3 to 4. And so what we're going to do is we're going to give you 4 examples, or we're going to give you 4 problems. You're going to pause the podcast, give them a try, and then we'll go back over them. Okay? So let's say in this first example that we have 3 moles of propane, C3H8. How many moles of oxygen, how many moles of O2 would you need to react with that? All right. In the next one, I want you to try this. If you start with 16 moles of water, and in fact that's a product, so we're going to make 16 moles of water. The question is, how many moles of CO2, carbon dioxide, would be produced with it? Of course, they're both products in this reaction. So how many moles of carbon dioxide would be produced along with 16 moles of water? Okay, next problem. Switch up here. Let's go orange. What if we have 11.25 moles of oxygen? How many moles of water vapor would be formed from the reaction of 11.25 moles of oxygen? And finally, what if we produce 29.37 moles of CO2? How many moles of propane must you have started with? All right, go ahead and pause the podcast. Give those 4 a try. Identify the mole ratios. Do the calculation, and then we can restart the podcast. All right, we're back. Maybe you actually did the work. Maybe you didn't, but we're going to go over it anyway. No problem. Here we go. So if we are currently in moles of propane, C3H8, and we want to go to oxygen, the mole ratio is going to be a 5 to 1. Again, if there's no number out here, we assume that that is a 1. So we have 5 moles of oxygen over 1 mole of propane, C3H8. Now again, how do you know what goes on top, what goes on the bottom? It's relatively easy to see that it's a 5 and a 1. The way you know what goes on top and what goes on the bottom is by looking at the units. If you have moles of propane here, it has to cancel with moles of propane down in the bottom. And now you have 3 times 5 is 15 moles of oxygen would be required to react with the 3 moles of propane. All right, let's try the next one. We're going from water to carbon dioxide. So here's the water, here's the CO2. And so we have moles of water here, so that means we're going to have to put the 4 moles of water in the denominator, and then we'll put the 3 moles of CO2 up in the numerator. So it's going to be a 3 to 4 ratio. So we have 16 times 3 divided by 4 is going to be, and actually I would go 16 divided by 4 is 4, and 4 times 3 is going to be 12 moles of CO2. Now again, you can multiply and divide these in any order that you want. That would be your preference. Next, going back to the orange, we're going from moles of oxygen to moles of water. So here is our oxygen up here. Here's our moles of water over here. We have a 4 and a 5. Or a 5 and a 4. We know that we want to get into water, so we're going to put our water on top here. So we have 4 moles of H2O on top. We're going to put the 5 moles of O2 in the denominator so that they can cancel out with those. So the moles of oxygen have divided out. We have 11.25 times 4 divided by 5 is going to be 9 moles of water. So 11.25 moles of oxygen in the reactant side will produce 9 moles of water on the product side. And finally, we're going from carbon dioxide back to propane. So we're right here with the CO2. We're going back to the propane, so it's going to be a 1:3 ratio. 1 mole of propane, C3H8, is needed to produce 3 moles of CO2. The moles of CO2 divide out top and bottom. 29.37 times 1 divided by 3 is going to be 9.79 moles of propane. So, I'm hoping that you are getting the hang of identifying these mole ratio. It is the key step in changing from one substance to another when making predictions, either determining how much product is going to be formed or how much reactant is necessary. In the next podcast, we're going to take a look at adding an additional step. We're going to weigh these out and incorporate the mass of the species. We'll see you next time.